All right, welcome back. We are still on Unit 1, which is one variable statistics, but this lesson is Lesson 5, calculating measures of center and variability. In today's lesson, we're going to calculate measures of center and measures of variability, and we're going to learn which are most appropriate for the data that we are given. Okay, we have mean and median. We need to know when to use which one. And we also have interquartile range and mean absolute deviation, and we need to know when it's appropriate to use each of those. Your end of unit test is going to require that you understand which one you should use in what scenarios. So our learning target that we want to keep coming back to in this lesson is going to be that you can calculate mean absolute deviation, interquartile range, mean, and median for a set of data. So by the end of this lesson, you want to ensure that you understand how to calculate each of those four statistics. Okay? So at the end of this lesson, if you still don't feel comfortable calculating those four statistics on your own, then please let me know and we'll work together to make sure that that gets clarified for you. So, as always, we start with our warm up. It should take about 5 minutes. And this one is warm up 5.1, titled Calculating Centers. It is available on Kitum if you would like to do it there, as well as in the workbooks if you prefer there. So we are going to go through multiple situations, and for each one, I'm going to read the situation, give you a minute to talk to those around you, and then you can decide whether you believe each one is true or false. So for the first situation, it says the mean can be found by adding all the numbers in a data set and dividing by how many numbers you had in the data set. Do you believe that's true or false? Take a minute, think about it on your own, talk to those around you, and then we'll answer it as a class. Okay? So for this one, the answer is true. Okay? Mean is a mathematical term that means average. So when we calculate the mean, we are going to add together every number in our data set. Then we are going to divide that sum by the number of data points we had in the data set. Situation number 2. The mean of the data in the dot plot is 4. So take a minute by yourself and then talk to those around you. Pause the video, and then we will come back and answer this question. So in order to figure out the mean on this data or this dot plot, you are going to need to be able to add together each data point. And this is what dot plots are really good for, because I know exactly what the numbers are, because every dot on my dot plot is one of my data points. So the first thing we need to do is add all of these together. 1 plus 2 plus 3, 3, 4, 4, 5, and 6. If we add this together, 6 plus 5 is 11, plus 4 is 15, plus 4 is 19, plus 3 is 22, plus 3 is 25, plus 2 is 27, plus 1 is 28. Now I'm going to take 28 and I'm going to divide that by how many points I had. So we have 1, 2, 3, 4, 5, 6, 7, 8. And 28 divided by 8 equals 3.5. So on this one, it said the mean of the data is 4. We calculated it to be 3.5. So this statement would be false. Situation 3. The median of the data set is 9 for the data 4, 5, 9, 1, and 10. So take a moment to talk to those around you. See if you can come up with a consensus about whether this is true or false. Pause the video, and when you think you have your answer, we'll come together and we'll answer it as a class. So unlike mean, which means average, median is the number that is in the middle of the data set. It is the number that will divide your data set exactly in half. And anytime I'm going to calculate the median, the very first thing I need to do is order my data set from least to greatest. So I need to arrange this in order, so that makes it 1, 4, 5, 9, and 10. Now, if I have an odd number of data points in my data set, then the number right in the middle is the one that is going to divide it in half. So in this instance, 5 is my number in the middle. This would be my median. That gives me 2 numbers to the left, and it gives me 2 numbers to the right. So 5 is my median. So this situation would be false. The median is 5, not 9. All right, situation 4 says the median of the data in the dot plot is 3.5. So again, the median simply means the number in my data set that divides my data set exactly in half. So if I have a dot plot, the first thing I need to do is count how many numbers I have in my data set, or in this case, how many dots are in my dot plot. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we have an even number of dots on our dot plot, then we need to find the 2 center dots. If I have 12 dots, that means I'm looking for dots 6 and 7. So when I go here and start at 1, 1, 2, 3, 4, 5, 6. So right here is my median. That gives me 6 data points over here. It gives me 6 data points over here. So in this case, none of my dots are the median. It would be the number that splits my dots in half. So if I have 3 and I have 4, I'm going to add those together, which equals 7. And then I'm going to divide by 2, and that gives me 3.5. So in this case, this situation is true. The median is 3.5. So now it asks, what does the mean tell you about the data? So take a minute, talk to those around you, and see if you can come up with what the mean tells you about the data. The mean is just another word for average. So the mean tells you the average of the data set. The problem sometimes with reporting the mean or the average is that really high values or really low values can pull the average towards that outlier. And we'll talk about outliers in a later lesson. Okay, so it does not divide it directly in half, it tells you the average value. So our next question says, what does the median tell you about the data? Take a moment to talk to those around you, and then we'll go over the answer as a class. Okay, so the great thing about a median is that it tells you the average in the middle. Okay. So the great thing about a median is that it does not get affected by very large values or very low values. Outliers don't affect the median. Okay? The median just divides our data exactly in half. So one area that this is really good for is if I was to report the median household income in an area, I don't want to use mean, because if there is a very rich person living there, then it's going to make the mean household income appear higher than it really is for the average person. What the median does is tell us the exact middle, so that half the people make less than that and half the people make more than that. That gives us a more accurate picture of what people living in that area make as a household. So that is the difference between average or mean and the median, which tells you the middle. Okay, our next activity is activity 5.2. This is titled Heartbeats, Part 1. It is available on Kidam or in the workbook, so whichever way you prefer to do it. We start out being told that the heart rates of 8 high school students are listed in beats per minute. They give us the beats per minute here. Notice they are not in numerical order. Question number 1 wants to know, what is the interquartile range? So talk to those around you and see if you remember from junior high what the interquartile range is, and if you can figure out how to calculate that. For number 2, they ask how many values in the data set are less than Q1, how many are between Q1 and the median, how many are between the median and Q3, and how many are greater than Q3. Remember what a quartile represents. Think about that word quarter. Okay. For question 3, a pod of dolphins contains 800 dolphins of various ages and lengths. The median length of dolphins in this pod is 5.8 feet. What information does this tell you about the length of dolphins in this pod? Question 4. The same vocabulary test with 50 questions is given to 600 students from 5th to 10th grades, and the number of correct responses is collected for each student in this group. The interquartile range is 40 correct responses. What information does this tell you about the number of correct responses for students taking this test? So this one gives us 10 minutes on the activity. Take 5 minutes, talk to those around you, see if you can work through questions 1 through 4 on your own in your group, see what kind of answers you can figure out, and then we will come back together as a class and discuss and make sure everyone understands how to calculate these. Okay, so for question 1, it wants to know what the interquartile range is. The interquartile range refers to the 5-number summary that we use to make box plots. The interquartile range is how far Q1 and Q3 are spread apart. So how large is the box in a box plot? So the very first thing we always have to do if we're going to talk about the 5-number summary, the median or the interquartile range, is to put them in numerical order from least to greatest. Now the only ones that we need to change, 72 is correct, then 75. Now we need to shift 76 and 76 down. Then we have 77, 78, 79, and 81. Now that they are in order, we can start to come up with our 5-number summary. We can always start with our minimum, which is our lowest number, our maximum, which is our highest. Our median divides this data set in half. We have 8 numbers in our data set, so we need to divide it in half right here. 76 plus 77 equals 153. 153 divided by 2 equals 76.5. So 76.5 is our median. Now we need to take the bottom half of the data set and we need to divide that in half. And this is going to be our Q1. We add 75 plus 76. That gives us 151. 151 divided by 2 gives us 75.5. So Q1 is 75.5. And to find Q3, we're going to take the top half of the data set and we are going to divide it in half again. This is going to be our Q3. Here we have 78 and 79. Add those together and we get 157. Divide 157 by 2 and we get 78.5. So our Q3 is 78.5. Now, in order to find the interquartile range, we are going to take Q3 and subtract Q1 from it. So in this case, that means we're going to take 78.5 and we are going to subtract 75.5. And that equals 3. So the interquartile range, or IQR, equals 3. Okay. Now, number 2 wants to know how many values in the data set are less than Q1, between Q1 and the median, between the median and Q3, and greater than Q3. So if we think about what it means to be a quarter, that means we're dividing into 4 equal parts. We had 8 numbers in this data set, so if I divide 8 by 4, that means each quartile is going to be 2 values. So we can see below Q1, I have 2. Between Q1 and the median, I also have 2. Between the median and Q3, I also have 2. And between Q3 and the maximum, I also have 2 values. So for this one, how many values are less than Q1? There are 2 values. Between Q1 and the median, there are also 2 values. Between the median and Q3, there are also 2 values. And greater than Q3, there are also 2 values. That's what a quartile does. It divides your data set into 4 equal portions. So if I have 8 numbers, 2 are going to be in each quartile. Number 3, a pod of dolphins contains 800 dolphins of various ages and lengths. The median length of dolphins in this pod is 5.8 feet. What information does this tell you about the length of dolphins in this pod? So the key here is that there are 800 dolphins and that the median length is 5.8 feet. Again, a median divides our data set exactly in half. So if there are 800 dolphins and we divide that by 2, that means there are 400 dolphins in each half. If the median length is 5.8 feet, that means 400 dolphins are shorter than 5.8 feet, and 400 dolphins are longer than 5.8 feet. That's what a median does. It divides our data set exactly in half so we know where the middle really is. This gives us a quick understanding that 400 dolphins are shorter than that number and 400 dolphins are greater or longer than that number. So we understand what kind of a normal or average, for lack of a better term, dolphin length is in this pod of 800 dolphins. Number 4, the same vocabulary test with 50 questions is given to 600 students from 5th to 10th grades and the number of correct responses is collected for each student in the group. The interquartile range is 40 correct responses. What information does this tell you about the number of correct responses for students taking this test? So if we pick this apart, we know that the test has 50 questions. We know that it is given to 600 students. And we know that the interquartile range is 40 correct. Well, if there is only 50 questions on the test, and our interquartile range is 40, then that would tell us, if we did a quick sketch of it on a box plot, I could have 0 down here, and we'll quickly sketch by tens. We don't know the minimum, and we don't know the maximum, and we don't know the median. But we do know the box size, because the outside of the boxes is made up by our Q1 and our Q3. And that's our interquartile range. It's the size of the box in a box plot. So if this is 40 in length, I could have a box that starts at 0 and goes up to 40. I could have a box that starts at 10 and goes up to 50. Or I could have a box that started somewhere in between 0 and 10 and ended somewhere between 40 and 50. But that box is going to be 40 answers long. So this tells us that the students scored all over the place. Some students scored high, some students scored low, but that middle 50%, which is the box on our box plot, is really long in relation to the actual number of questions on the test. So this tells us there was a large variability in the scores on this test. And logically thinking about it, if I gave the same vocabulary test to kids between 5th and 10th grade, that's what you would expect. You would expect 10th graders to score much higher than you would expect 5th graders to score if the test was about the exact same words. So in this case, logically, we expect 5th graders and 10th graders to score very differently than each other. And when we see the data, we in fact find out the interquartile range of 40 out of 50 means we had a very large variability. So some questions to think about. What would a box plot look like for the results of the vocabulary test? That's what I drew right here. We are going to have a box plot with a very large box. This question, what does the IQR tell you about a data set? The IQR tells you the variability. It is a measure of how widely spread out your data set is. If you have a very small IQR, then most of your data is very tightly packed. So if I have a small IQR, then I might see a box plot that looked like this. If I had a large IQR, then my values are very spread out, and I might have a dot plot that looked like this, or a box plot that looked like this. The larger the IQR, the more varied or spread out my data set is. The smaller the IQR, the closer together and the less varied my data set is. How do the median and quartiles divide the data? The median divides the data in half. And the quartiles divide the halves in half. So it divides the data into quarters. And lastly, how much of the data is between Q1 and Q3? Q1 to Q3 is 50% of our data. It is the middle 50% or the middle half of our data. It is where most of our data is centered. So now we have activity 5.3. This should take us about 15 minutes. It is called Heartbeats Part 2. It is available on Kidem if you prefer to do it on the website, or in your workbook if you prefer to work on paper. Or again, you can always go up to one of the whiteboards that are around the room and do the work on the whiteboard if you prefer. So on this slide here, what we have is an example of how to calculate the mean absolute deviation, or the MAD. So when we think about this word, we have mean, which means average. We have absolute, which in math means positive value. And we have deviation, which means spread. So that's exactly what we're calculating here. If you notice, they give you a table of values. These in the first column are the actual data values in our data set. The second column is our mean. So we expect this to be the same all the way down because we only have one mean value. What they're doing is they're subtracting 1 minus 5, 2 minus 5, 3 minus 5, and so on. And that is how they get the numbers in the third column. 1 minus 5 is negative 4, 2 minus 5 is negative 3, 3 minus 5 is negative 2, and so on. The fourth column is our absolute deviation. Absolute value in math just means the positive value. I don't care whether the value is below or above. I only care how many spots away it is on a number line. So all they do is take the number in the third column and make it positive. So negative 4 becomes 4, negative 3 becomes 3, negative 2 becomes 2. Then they take each of these numbers and they just add them together. 4 plus 3 plus 2 plus 1. And that is what they show right here. So now is where we get into the mean portion of this. Remember, mean is another word for average. So I add all of my absolute deviations together, then I divide by how many numbers were in my data set. In this case, there were 8. So if I add 4 plus 3 is 7, plus 2 is 9, plus 1 is 10, plus 1 is 11, plus 2 is 13, plus 7 is 20. So what I really have is 20 divided by 8, which is 2.5. So in this case, our mean absolute deviation is 2.5. What this tells us is, on average, how far away from the mean are all the points in our data set. So in the previous exercise or activity, we used median and we calculated the interquartile range, or the IQR. You will always pair the median with the IQR. Now we're looking at mean and mean absolute deviation. You will always pair those two together. So in your activity, they give you the data values from our previous activity. We go back to the heartbeats. It asks us to calculate the mean and fill out this column, then calculate the deviation from the mean, taking our data value and subtracting the mean, and then take each of these values, turn them positive, and put them in the fourth column here. Then we can calculate the mean absolute deviation from this last column. So the very first thing we need to do is add all of these data points together. So we have 72 plus 75 plus 81 plus 76 plus 76 plus 77 plus 79 plus 78. We get 614. Notice I did not have to put these in numerical order. With mean, I'm taking the average, so I just need to add them all together and then divide by how many there are. So in this case, when I add them all together, I get 614. I had 8 data points. So now I can divide by 8, and I get 76.75 as my mean. So that is what I would put in here for my mean. And you would write the same thing in all of these spots. So then what you need to do is you need to subtract. So you're going to do 72 minus 76.5, and you're going to get negative 4.75. 75 minus 76.75, and you're going to get negative 1.75. 81 minus 76.75, and you're going to get 4.25, and you're going to continue to subtract. So negative 0.75, negative 0.75, 0.25, 2.25, and 1.25. Now that we've gotten all of our deviations from the mean, we now need to make them absolute deviations by making sure they're all positive. So negative 4.75 just becomes 4.75. Negative 1.75 just becomes 1.75. A positive number stays positive, and each negative becomes positive. Now that we have all of our absolute deviations, we need to find our mean absolute deviation. So we're going to add them all together. 4.75 plus 1.75 plus 4.25 plus 0.75 plus 0.75 plus 0.25 plus 2.25 plus 1.25. And this gives us a total of 16. So now I can take 16. I'm going to divide it by how many data points we had, which is 8. And 16 divided by 8 is 2. So our mean absolute deviation equals 2. So now they're going to give us some questions about mean absolute deviation. It says we have another data set, not the heartbeat one that we were just doing. It says for another data set, all of the values are either 3 beats per minute above the mean or 3 beats per minute below the mean. Is that enough information to find the mean absolute deviation for this data set? If so, find the mean absolute deviation. If not, what other information is needed? Explain your reasoning. Question 2, several pennies are placed along a meter stick, and the position in centimeters of each penny is recorded. The mean position is the 50 centimeter mark, and the mean absolute deviation is 10 centimeters. What information does this tell you about the position of the pennies along the meter stick? So take a few minutes, talk to your neighbors, and see if you can come up with answers to questions 1 and 2. Then we will come back together as a class and work through them to ensure everyone understands what we're doing. Okay, so for question number 1, we need to think about the information they give us. It says all of the values are either 3 beats above or 3 beats below. So that means every single one of my deviations is going to be either -3 or 3. But then I'm going to take the absolute deviations. -3 is going to become 3. Every above is going to stay 3. So now, no matter how many of these I add together, I'm going to add 3 plus 3 plus 3 for every single point in the data set. And then I'm going to divide by the same exact number of 3's that I put here. So if I take 3 plus 3 plus 3, and I get 9, and then I divide that by the 3 points here, I'm going to come out with 3. So no matter how many points are in the data set, I still know that in the end, my mean absolute deviation is going to be 3 beats per minute. So they didn't actually have to tell me what the mean was. They didn't actually have to tell me all the points in the data set, simply by understanding that all of them are either 3 above or 3 below, and knowing that no matter whether they're 3 above or 3 below, as soon as I take the absolute value, then I'm saying they're all 3 away from the mean. So no matter how many times I add 3 plus 3, if I then divide by how many numbers there were, my answer is always going to be 3. So yes, we can still calculate the mean absolute deviation. It's going to be 3 beats per minute. Question 2. Several pennies are placed along a meter stick, and the position in centimeters of each penny is recorded. The mean is the 50 centimeter mark, and the mean absolute deviation is 10 centimeters. What information does this tell you about the position of the pennies along the meter stick? Well, this tells me that on average, my pennies are either 10 centimeters beyond, so around the 60 mark. So if I've got my meter stick here, I've got 50 in the middle, and my mean absolute deviation is 10 centimeters, then 10 centimeters above that would be 60, 10 centimeters below that would be 40. So on average, my pennies above are centered around 60, and my pennies below are centered around 40. That's what the mean absolute deviation tells me in this instance. So now that we're back as a whole class, we'll look at these last few questions. It says, if you put pennies at 45, 35, and 70, where do you need to put a penny for the meter stick to balance at 50 centimeters? So if you think about this, if I have a meter stick and we want it to balance at 50, then 45 is 5 below. And 35 is 15 below. And then I have one out at 70, which is 20 plus. So now I have negative 20 down here, and I have positive 20 up here. So this meter stick is already balanced. So the only place that I can put another penny and keep it balanced is to put my penny at the 50 meter mark. The 50 centimeter mark. Okay? The next one says, if you put 2 pennies at 60, where do you need to put a penny to make the meter stick balance at 50? So if we think about this logically, I want to balance it at 50. I have 2 pennies here at 60. That means each of them are at plus 10. So that's going to be a total of plus 20. Now I need to balance this, so I need down here to be negative 20. That means I need to place a penny at the 30 centimeter mark so that I'm negative 20 down here and I'm plus 20 up here to balance them. Okay, so we will look at these last few questions just to synthesize the lesson for today. So the first one here says, how do we calculate the IQR? If you remember, the IQR is the interquartile range. That means how far is it from Q3 to Q1? So that gives us the IQR. So you need to put the numbers in order from least to greatest. Then you need to find the median. Then divide the lower half in half to find Q1. Then divide the higher half in half to find Q3. Then you subtract Q3 minus Q1, and that gives you your IQR. So IQR will always pair with your median. The second one asks, how do we calculate the mean absolute deviation? So the first thing you need to do is calculate the mean. Then you subtract the mean from each data point. Then we take each value that we just got for our deviation and we make them positive. Then we add all of those absolute deviations together. And finally, divide by the number of data points. The last question says, one data set has a greater IQR than another. What does this mean about the data in the first set? The IQR tells you how spread out your data set is. So the larger the IQR, the more spread out your data points are. The smaller your IQR is, the closer together your data points are. So if the first data set has a greater IQR, then that means the first data set is more varied than the second. That is what an IQR does. It is a measure of variability. It tells you how spread out your data points are. So now we have the cooldown. It should only take about 5 minutes. This one is called calculating mean absolute deviation and interquartile range. Remember that a cooldown must be completed on the KIDM website. So if you haven't already logged on, then make sure you do. Make sure you complete this cooldown on the KIDM website. Also remember that cooldown tickets are meant to be individual, so don't work with those around you. This is for me and the district to understand how well you understand the information up to this point. So try your best and make sure you submit it through the KIDM website. They are going to give you 5 data points as well as the mean. They want you to be able to use this information to calculate the mean absolute deviation and to be able to calculate the interquartile range. You have all the information here that you need to calculate both of those. So take about 5 minutes and make sure that you understand how to do this and enter it in. Finally, we'll just finish up with our glossary terms. We are still talking about the shapes of the distribution, only this time we can relate the shape names to the mean and median, as well as the interquartile range and the mean absolute deviation. What I mean by that is, when we talked about mean and median, I said that the problem with a mean is that because it's an average and we calculate that by adding all the values together, this can be distorted by extremely high values or extremely low values. An outlier will pull the mean towards it. So we can only use the mean when we have symmetrical data, because that means we don't have outliers. So if I look at a bell shape, I have just as many points to the left as I do to the right. So I could use the mean for this and the mean absolute deviation. There will be questions on your test that require you to understand how the shape of a distribution changes which measure of center and which measure of variability you use. So if you have bell-shaped distribution, which makes it symmetrical, then you can use the mean and the mean absolute deviation. Our next one is bimodal. Remember, bi means 2 and modal means peaks. When we look at this, if it happens to be symmetrical, then you could use the mean and the mean absolute deviation. But if you look at this data set, they are not symmetrical. The right side has more points on it than the left side does. So because this is not symmetrical, you have to use the median and the interquartile range. So symmetrical data allows you to use the mean and the mean absolute deviation. Non-symmetrical data requires you to use the median and the interquartile range. Here we have skewed. We see the majority of our data is on the right. The tail is to the left. So this would be skewed left because the tail is to the left. Because this is non-symmetrical, that requires us to use the median and the IQR. Symmetrical distribution simply means I could fold this data in half and it would look the same on both sides. If it's the same on both sides, that means there's no outliers, and therefore it is symmetrical. I can use the mean and the mean absolute deviation. And finally, uniform data. Uniform data means it looks fairly the same all the way across. In this case, this uniform distribution is symmetric as well. If I folded it in half, it's going to look the same. There's no outliers on the low end. There's no outliers on the high end. So I could use the mean and the mean absolute deviation. So just to finish up with, I want to go back to the learning target. This is what you want to be able to say, you are confident you can do this. So if you are confident you can calculate the mean absolute deviation, the interquartile range, the mean, and the median, then you are good to go for this lesson up to this point. You're on track for doing really well on the end of unit assessment. So good job. If you are still not quite comfortable saying that you can calculate these 4 statistical values, then ask me about them, ask your friends around you, and let's make sure we get you on track to feeling absolutely comfortable calculating these before your end of unit assessment, because these will absolutely be on your end of unit assessment. So if you were here in class, thank you for your participation. If you were absent, thank you for going online and watching this so you can stay up to date with what we're covering. And if you just needed to go back and rewatch this, even though you were in class, thank you for putting in that extra effort to make sure you understand and you are prepared before your end of unit assessment. So thank you for watching this, and I will see you in the next class.